Hi everybody, today we're going to talk about using the normal distribution, and I'm going to show you steps in Desmos. In this video, we're looking at normal distributions that are not standard normal distributions, meaning our mean and standard deviation aren't 0 and 1. Because the mean and standard deviation are not 0 and 1, we just need to enter them into Desmos to let it know how to adjust the normal distribution to fit our data set. Let's start with a data set that is normally distributed with a mean of 14 and a standard deviation of 3.9. We'll find the probability that x is less than 16, greater than 7.4, and between 11 and 15.7.
The first thing we need to do is go to Desmos and let's type in normal dist. Next, we want to enter our mean, which was 14, and our standard deviation of 3.9. Let's hit the magnifying glass to zoom fit our graph. Notice when I click at the top dot, you can see our mean of 14. Now we want to find the probability that x is less than 16. I'll hit my arrow down by cumulative probability. Because we're doing less than, we know that's to the left. Let's put in our value of 16, which says our probability is 0.696. Remember, you can always get more decimals by clicking the arrow down. Next, we want to find the probability that x is greater than 7.4. Greater than goes to the right. We'll change our bound to 7.4, which gives us a probability of 0.955. To get the probability that x is between 11 and 15.7, we'll click enter. We'll change the left bound to 11. We'll change the right bound to 15.7, which says our probability is 0.448.
Next, let's try an application. We're given that the volume of an espresso is normally distributed with a mean of 0.85 ounces and a standard deviation of 0.8. We want to find the percent of espressos that are between 0.8 and 0.9 ounces. Then we're also going to find the percent of espressos that are over 1 ounce.
To find the probabilities, we'll go back to Desmos and we'll change our mean and standard deviation. Our mean is 0.85. Our standard deviation is 0.08. We first want to find the probability that the espresso is between 0.8 and 0.9 ounces. That's between two values, so we'll stay on enter. We'll make the left bound 0.8. We'll make the right bound 0.9. Let's hit zoom fit to readjust our graph to our new mean and standard deviation. The probability that the espresso is between 0.8 and 0.9 ounces is 0.468 or 46.8%. Next, we want to find the probability that the espresso is greater than 1 ounce. Greater than goes to the right. We'll change our bound to 1, which says our probability is 0.03 or 3%.
Our next problem says, assume the weights of quarters are normally distributed with a mean of 5.67 grams and a standard deviation of 0.07 grams. If a vending machine will only accept quarters that weigh between 5.5 and 5.8 grams, let's find the percent that will be accepted and the percent that will be rejected.
We'll once again change our mean and standard deviation. This time our mean is 5.67 with a standard deviation of 0.07. Because we know the weights that will be accepted are between 5.5 and 5.8, we'll go to enter. We'll put a left bound of 5.5 and a right bound of 5.8. Let's hit zoom fit to get a look at the graph. We can see that 0.961 or 96.1% of the coins will be accepted. To get the percent that would be rejected, we could do 1 minus 0.961, which is 0.039, or we can change our region from inner to outer. This shows us that the amount outside of the 5.5 to 5.8 is 0.039.
Our last application says the number of people that ride an amusement park roller coaster is normally distributed with an average of 1,200 passengers per hour and a standard deviation of 300. We're going to find the percent of the time there will be less than 800 rides per hour, the percent of time there will be more than 1,500 rides per hour, and the percent of time that there will be between 1,000 and 1,650 rides per hour.
Let's adjust our mean and standard deviation. For this problem, we have a mean of 1,200 and a standard deviation of 300. Let's also hit zoom fit to get a look at our graph. We'll start with the probability that we had less than 800 riders. Less than goes to the left, and we put in our bound of 800, which gives us a probability of 0.091. Next, we want to know the percent of time that we had more than 1,500 riders. More than is greater than, which goes to the right. When we put in our bound of 1500, we get 0.159 or 15.9% of the time. Then finally, we want the percent of time that we'll have between 1,000 and 1,650 riders. So we'll click on Enter and adjust our bounds to 1,000 and 1,650, which gives us a probability of 0.681 or 68.1% of the time.